Hello, my nerdy Nawg-Dawgs, and welcome. This is week 7, and this is your science mini lesson. In your live session today, you would have done a science experiment. I can't wait to hear all about it. You guys will have to post and let me know your final outcome or take a photo for me. Meanwhile, we do have some bookwork to do. And so your mini lesson today is really focusing on what you will be reading about and bringing in a lot of our prior knowledge, because you guys do have a lot of prior information on this. All this month, we've been talking about fast changes on Earth. Oh my gosh. So today we're talking about volcanoes, and volcanoes are definitely a fast change on Earth. And this is chapter 5, lesson 3. So let's get started, shall we? This is kind of what you'll be reading about, our fast changes on Earth. Okay, here we go. Let's begin. Volcanoes, my friends. Surprisingly, as I was going through this, there is so much that you guys already know. So turn it on. Time to double tap. Take a deep breath in. Nerdy Nawg-Dawgs at hand. Open up, and here we go. Okay, volcanoes, what do you know? There's a lot that you know already. In fact, you have actually held volcanic matter in your hands in the classroom. This is a picture of some basalt rock, and we did pass around the basalt rock one day, and obsidian. Obsidian, one of my favorites. I mean, how spectacular is that black shiny rock? So you have actually held these in your hot little hands. Well, can I remind you? This is volcanic matter. These are volcanic rocks that were once hot, molten lava. And once that lava has dried, it turns into obsidian, basalt. There's a couple others that it turns into too. However, these were the two that I was able to share with you in the classroom. So that hot molten lava, also known as magma, you should be somewhat familiar with, because we've talked about it in our rock cycle. Do you remember what kind of rock this is? Igneous, of course. Igneous rock means of fire. So this is igneous rock, and here's a couple beautiful photos of volcanoes. Now, why I bring this up is we did a whole experiment on this. It was our first, maybe our second week of independent study. So you did an experiment. Do you remember? You had a cup. You had some ooey gooey flour type liquid. One was thick and chunky, thinking of our video that we watch in class. And one was really thin and loosey-goosey, right? Okay, so any bells ringing? Come on, people. Nerdy Nawg-Dawgs, you should recall, this was all about volcanic eruptions. So if you remember our experiment, we were already dipping into the hot molten lava volcano. All right, here's a couple glorious pictures. Not bad, eh? Really beautiful. Okay, so in our experiment, we were actually talking about what types of volcanoes these were and how we knew. And one thing that Doug brought up was he kept talking about this shape. So if you notice these ones on the left, they have something in common. I think that might be, oh, is that Mount St Helens down below? Not quite sure, but they have something in common, and they definitely look different than the volcanoes on the right. Is our experiment standing out yet? Are you coming up with any ideas? Come on, people. The ones on the right are called shield volcanoes, where the volcanoes on the left are called cone volcanoes. I think that's pretty apparent as to why, right? The ones on the left are pointier, but if you recall from our experiment, there's a reason they're pointier. So let me refresh your memory, my nerdy Nawg-Dawgs. If you don't recall, let us move on. So here we go. Thin versus thick lava, magma. There is a slight difference, and there's a slight difference to the type of volcano they then create and build. So the thick and pasty kind, Then as it forms, it continues to build what we call as a cone volcano. And in fact, I mentioned this earlier, Mount St. Helens in Washington is a cone volcano. Ooh, I hope I included the photo. Let's see. So it forms a cone, right? And there's a reason for that. We'll get to that in just a moment. You might be pulling from your prior knowledge because our experiment did kind of touch on this. So here's a picture of Mount St. Helens after it exploded. Oh my goodness. And this was several years after it exploded. I don't know when. I didn't write down the date. But if you notice, already right in the middle there, let's see if I can highlight that a bit. Let's get my highlighter on. Do you see what I see? A brand new cone forming. Isn't that so cool? So although there's this big crater from where Mount St. Helens blew its top, it has already begun to form a brand new cone in the middle. And over many years, as it continues to let off steam, it should continue to form a brand new cone. Kind of cool, right? Yeah. Okay, let's see. Moving on. So why did Mount St. Helens explode? Because if we go back, and I don't know that I mentioned that, but this is what it looked like before. And this is what Mount St. Helens looked like after. You see that big gap in the middle, the big crater, and that's because it exploded. It is what is known as a cone exploding volcano. Okay. And that is because it had very, very thick lava brewing beneath. And then as those air bubbles and different vapors continue to collect at the top, it builds in pressure because this lava hasn't come out yet, and it's building, and as those vapors and bubbles form at the top, all of a sudden the pressure can take no more, and it explodes in gases, in flying lava. So that exploding kind of volcano, a cone volcano, often leaves us with the basalt. Remember how light and airy that rock was? That's because there's all those air bubbles in it. And then as it hardens and dries up, it dries nice and light and airy, not like the obsidian. Okay. So we also talked about the thinner lava. And when you guys blew in your straw, what happened? Do you remember? Come on, nerdy Nawg-Dawgs. When you blew in your straw of the light, easily flowing lava, the bubbles continued to pop and just come up. Well, guess what? With the light flowing lava, it creates that shield. Because it doesn't form, it continues to just ooze and goose and fall out, and it doesn't form a cone shape. So here's an example of an oozy-goozy volcano, or what we would call a shield volcano. Mauna Kea in Hawaii is a famous shield volcano. Guess what? It is almost always erupting. You know what's cooler than cool? It doesn't necessarily erupt out of the top. It has these underground canals that lead out underneath the surface and the Earth's crust, and then continue to flow into the ocean. And when it gets to be too much, it does overflow from the top, continuing to add on to this nice shield because it just drips down the side. Okay, so two different types of lava flow create the two different types of volcano, a cone volcano or a shield volcano. That stuff you should be familiar with. It's in your textbook again, and that's why we're reviewing it. in our experiments, you also brought up the Ring of Fire. And then just a couple weeks ago with earthquakes, we were talking about the Ring of Fire again because we were talking about the tectonic plates. So all along the Ring of Fire, well, the Ring of Fire is all along the Pacific tectonic plate. Okay, as you see in this picture, all along that plate are little breakouts of volcanoes. So we know that there's constant movement under the Earth's surface and on the Earth's crust. We know that there's even volcanic movement under the Earth's crust. Isn't that kind of neat? Can I tell you a secret? We actually had a lot of thermal activity really close by. And way back in the early 1900s, like around 1910, there were Japanese bathhouses down in San Pedro at the beach. And that was because there was thermic activity. And so they built these indoor swimming pools on the ocean seafloor. And if you go to White Bluff, you can actually still see the platform of this building. And they were indoor bathhouses where there was thermic activity, meaning warm gases coming up from the ocean and warming up the water. So they had an indoor little swimming pool where people could go and swim in the ocean water, and they thought of it as healing, having healing properties. Right there in San Pedro. How cool. Now, at some point there was an earthquake and that sealed up that opening, and there's no more thermic water coming to the surface. So, or coming up on the Earth's crust there, warming the water. Unfortunately, because that sounds really lovely. Till there's a volcano. Okay, a little bit of local history. So what I want you to recall is that this is part of the rock cycle, right? Volcano explodes, igneous rock flows out. As it dries up and hardens, that then turns to rock, solid rock. And then that breaks down and there's weathering, which we know something about too. We were learning that about 3 weeks ago. And the weathering carries away these different sediments that break off of the rock. The rock then becomes maybe larger portions of sedimentary rock or get carried around and weathered away. And then what happens is over time that gets layered and layered upon, right? The sediments get layered and layered and layered and layered. And then way down deep, if you remember me saying that, down deep, because of all the pressure and all the weight of the Grand Canyon on top of it at the Earth's crust, it forms metamorphic rock where the rock fuses together from the heat and the pressure. And that's where we get all of our lovely rock that we use for our countertops. That's where we find marble and stuff. Way down deep. And then what happens is there's always pockets of magma and from the heat from the Earth's insides, Earth's core, that kind of flow through these different pockets. So that metamorphic rock might get melted away and turn into magma. And then the magma follows these different channels, and maybe some will continue to drizzle out like our little shield volcanoes, or maybe it explodes and it all starts again, the rock cycle. Okay, so we have talked about that. You guys know all about that. This is just constant. There is constant change here on Earth. Always keep that in mind. Okay, now here's some volcanoes in action. Now, it's always a little bit iffy whether my videos are going to work. If this does not work, oh dear, it might play. It's happening rather slowly.